So we're going to be talking about a problem from the closure, chapter 6-7 closure, CL7121. So this is a proof, and this is what's known as a two-column proof. Now, we haven't really been introduced to two-column proofs because I didn't do that lesson. There's nothing to it, really. But I like flowchart proofs better, and we're going to spend most of our time with flowchart proofs. So I'm going to go ahead and do this, but I want to just kind of, we'll just move through it. So Kelly started a proof below to show that TC and TM are congruent. So she's trying to demonstrate that two sides are congruent, and she doesn't know that yet. And excuse me, let me restart. TC and TM are congruent if, excuse me, I didn't read the word if. TC and TM are congruent and TA bisects CTM, then CA and MA are congruent. So you'll notice that right here it says congruent triangles in this proof, so I'm going to have to find some congruent triangles. So what we're going to do is really simple. The first thing we're going to do is take this format and turn it into a flowchart format so we can handle it, because we don't know how to deal with this. So we're just going to start by redoing this. Okay, so I have it right here in the corner so I can see it. Probably not the most readable thing in the world, but it'll help me. So the statements are the bubbles. So I have a bubble, and in that bubble I write TC congruent TM. What I'm missing is the line underneath that tells me what it is. Why? I know that. Then I have another bubble, AT bisects CTM. Angle CTM. And again, that's a bubble. That is dreadful. Got some weird things going on. Let's see what I can do here. Nope, can't do anything with that. Yeah, okay, it's all good. We'll leave it. Bubble. And again, we are missing the reason. So the reasons are the lines that go under the statement we put underneath the bubble, and the statements are the bubbles. Then we have another bubble with nothing inside of it for number 3, definition of bisect. Okay, and this bubble is probably going to be connected to that bubble. So I'm going to go ahead and move this over here. It's going to be my way, but it's going to go over here. So since I moved that over there, I will also, at the same time, I'm going to grab this and just move it out of the way. There, not in the way there. And then I have another bubble, AT congruent to AT. I'm going to do a different color here. Okay, and again, I don't know the reason. Then I have a bubble and a blank, and I don't know anything about it. Bubble with a blank. And then I have a final bubble. Again, no idea what's going in there. Congruent triangles, arrow congruent parts. Now this is on my final bubble. So all the arrows will eventually, if I follow them down, will take me to this bubble. And here's the key to every proof that you ever do in your whole life, especially when you're filling in somebody else's blanks. So if you're making it from scratch, this is not, I mean, it's still true, but this is what I'm trying to show. This is what I'm trying to prove. CA is congruent to MA. And that's the end of my proof. Once I've shown that, my proof is done. And if I haven't shown that, my proof is not done. Let me explain what I mean in just a second. Let's go ahead and see if we can fill in our blanks. TC and TM are congruent. So that was given information because they told me that, right? That if TC and TM, TC, TM, if they're congruent, so that's given. AT bisects CT, angle CTM, that's also given. I want that to be different color. Both of those given. So the green is what I'm adding to it. We're going to have to put some arrows on here because the one thing that I dislike about this is the connections with the flowchart totally handles. It's one of my favorite things about a flowchart. So TCTM, I don't think that leads anywhere, but bisect, oh, definition of bisect. So clearly I used this. These two are attached. There's an arrow that this leads to that because it says definition of bisect, and that says it bisects. See how that's connected. And so what does it mean that it bisects? Bisect means to cut. And it doesn't mean to cut. It means cut into. So sect is cut, bi is to, so this is cut into. So this has been cut, the angle has been cut into equal pieces. Cut into two equal pieces. Okay, so angle ATC is congruent to angle ATM. So AT is my side, that's where they both started. And then I finished at the two letters on the outside since T is part of AT. Right? If that makes sense. And that's the definition of being bisected. Okay, AT is congruent to itself. This bubble came from out of nowhere. It's not related to that. It's not related to that. It doesn't have an arrow pointing at it. The only things that cannot have arrows pointing at them are givens, or there's two properties we can use without attaching them. One of them is the reflexive property, and that's what this one is. The reflexive property. And it's reflexive because I'm saying, hey, it's congruent to itself. It's coming from out of nowhere. I don't need it to be. And you can say, because line segments are congruent to themselves. That is a perfectly correct choice here. I like reflexive property. It's what I'm looking for, but I'll take the other. So we have our bubble from nowhere, and then we have congruent triangles. So what we're going to do is we're going to show two triangles are congruent. Which two triangles have we shown are congruent? Well, triangle ACT. Let me change colors again. A triangle, ACT, ACT, congruent to triangle AMT, AMT. I should have done ATM, but then the other one doesn't work out. ATC, ATM's better. But there we are. And that would be side, angle, side. Now, where are the arrows? So one of them is this side, there's another side, and there's an angle. And that's why I like about the flowchart proof is that following the arrows, I can say, oh, what is it? Well, I've got two sides and an angle. And this angle is in between them. I used a picture to kind of tell me that. Because we know that this one does not work. Neither does the backwards version of it. Does not work. It's not proof triangles are congruent. Okay. Then last we have congruent triangles, congruent parts. That arrow is clearly coming from this. Since I have congruent triangles, I have congruent parts. Which parts? Well, maybe these two that I'm trying to show. CA congruent to MA. Let's check. Are those pieces? Oh yeah, that's these pieces out here. Congruent triangles, congruent parts. And that's, again, what I'm trying to show. Last thing. Then my proof's done because I've shown what I was trying to show. Does that make sense? So that's kind of the idea, the flow. And again, I like this much better than this. This is what I learned in school, and I hated it. Then I was in college and I learned how to do something else. I never learned this. But when we were in college, we were talking about this. Well, what does that tell you? And what does that tell you? And we wrote what was called paragraph proofs. We'd write like essay proofs, if you will. You have to be proving something a lot more complicated than this, but that's the idea. We're not writing essay proofs. We're writing flowchart proofs because they're really basic. Okay, but that's the idea. So I hope that's helpful. And I hope you can then finish the closure with this video in mind. Have a great day. I'll see you guys later.